Now we
Okay.
see your presentation. Not your face though, just the presentation. But
Okay. It's good. The focus, is on the presentation of my face.
okay, okay.
Okay, we can go. Okay. Let's go.
Yes.
So this is my face, so you can see my face. Paolo and Marco are the two people of my team that helped me with this presentation. And let's go on the presentation because it's not important who we are, but the topic, blockchain and IBMI. We're gonna have a meeting and the presentation, a webinar, and with Torbjörn, we decided to do this as an open meeting because we think there can be a discussion around this topic. So feel free to stop, to make questions, whatever you want. Okay, the presentation is short. We'll see an introduction to EVM and smart contracts. EVM stands for Ethereum Virtual Machine, and now we'll see what is it. An architectural overview of the use case we designed and the tools we designed around this topic, and some usage in our software, because it is for us it's simple to know, to explain and to use our software as an example, and we'll see some RPG code templates for the RPG people, for the developers to use this solution. Ethereum Virtual Machine is the distributed virtual machine behind one of the most famous blockchains, that is Ethereum, but it is used also in other blockchains. The thing is, Ethereum Virtual Machine handles smart contracts. What are smart contracts? Smart contracts are, we have here an example of smart contracts. As you can see, it's just code. Okay, code written in Solidity. That is a proprietary. It's a specific programming language for blockchain, for EVM. What is important here is that the EVM is the machine, a state machine that executes this code. Okay, so smart contract for who between you who in this group doesn't know what is a smart contract. A smart contract is just a code. They gave it a terrible name, but it's just code. Is it's more like a Lambda function than a contract. Okay, and this code is put into the blockchain, and the blockchain makes it immutable. And thanks to the Ethereum Virtual Machine, it makes it executable. Okay, it can execute. And so what we did is write a smart contract for some usages in the ERP world, because we are ERP developers, and what we wanted to do is, first of all, use the blockchain, because it makes easier to secure data and information. The uses of blockchains are very wide. The purpose of this presentation is not to understand the blockchain technologies and things like that, but to go more into the technical details of programming and what you see our way to use the blockchain. And I put this for ERP use cases, but we are not going through every use case. It's just a note for who will have the presentation after this meeting. So I'm going to continue. What we built in SMAP as a company, because our company SMAP has the same name of our software SMAP, so we can maybe there will be a little confusion around this. I'll try to make it clear. Okay, we built SMAP blockchain, SmartKit blockchain, that is a bundle made of 3 components. We have one smart contract, okay, a smart contract in Solidity, and can be so it can be executed on every blockchain using EVM as a standard, as I said before. Okay, and this smart contract we developed is meant to use the blockchain as an immutable key value store. So in our smart contract, we just put the code that handles a key and a value, okay, and also the version support, as we will see. So the smart contract is it has 2 operations, basically 2 operations. Put a key value, so put the couple, here is a key, here is a value, put it on the blockchain, and here is the key, retrieve the value from the blockchain by key. Okay, then we developed a microservice. This microservice is written in Golang because Go is has a lot of libraries. It's because it was way easy to develop in Go, and because it's the language, the more used language in the Ethereum world. Okay, and we had a lot of help with using this language, but there are a lot of libraries also in Java, in Python, in I guess C, and other mainstream languages, not in ERP. Sorry, in RPG. Okay, and we also support version, is something we'll see. No, sorry. Okay, and of course the microservice interacts with the blockchain. Why we did this microservice? Because that is the point where the system scales. Okay, is through the microservice that we can manage the scaling in case we have many users. If we have a lot of users, if you want to put this microservice in cloud or on premise, the microservice enables this kind of problem, this kind of problem solving around the distribution of the service. And we made an RPG API, so RPG code that can be used inside an RPG program where needed. I mean, because this blockchain, this bundle can work with microservice and a smart contract. With just the microservice and smart contract, you don't need to have an RPG API. This is for making it very easy for the RPG developer to use it. So we have IBMI and the RPG API that we'll see later. We have this microservice, and we have the smart contract. The dotted line is our solution that we call the SmartKit blockchain. Okay, as I said, it can be used by SMAP, the software that is written in RPG and works on IBMI, and these are some modules of SMAP ERP, or we call it SMAP data platform. From other ERPs, for example, this RDS is one of our ERPs. Other ERPs we develop and own in our company. This is one of our document management system, and these two are not written in RPG, so they can interact with the SmartKit through HTTP, okay, because this market exposed HTTP endpoints. And IoT Ready is our IoT software solution. We'll see an example later. Okay, so this market is meant to be used from every software that can handle HTTP APIs, and in SMAP, we in the SMAP software, in RPG software, we wrapped the communication inside RPG API. Okay, using EVM makes the microservice compatible with a lot of blockchains. Okay, this is Ethereum. This is Hyperledger Fabric. This is the one distributed the IBM blockchain, and there are other blockchains using EVM. This is important because every blockchain, as you may know, or maybe you don't know, but every blockchain has different properties. For example, it can be open or public or private. It can be slower but more secure, or faster and less secure, things like that. And so you can choose, or we can choose, because we built it for our purpose. We can choose different blockchains following the different needs of our customers. Okay, the key concept of our approach. First of all, the goal is to support ERP use cases. Okay, so not every use case, but we want to support ERP use cases with a little effort for ERP developers, for RPG developers in this case, but for every kind of developer, because as we said, it's meant to be used with HTTP API from by everyone. Okay, and this is made by keeping the using hashes of key and data. Okay, so the SmartKit only handles the hash of the key and the hash of the data. And so the plain data remains on the source system, or in the source system. And what is in the blockchain is always readable. This is how we decided to do it. It can be changed, of course, but this sounds to us very useful, very generic, and also more secure and efficient. Okay, just a few words about versioning. As I said, this solution, this SmartKit, as we called it, uses the blockchain as a key value store. But every time you put a value using the same key, the smart contract adds, because you cannot change the value, adds a value as a new node. Okay, so with the same key we have multiple versions. We have this I called it a commodity, because you can use only if you want, you can use just the last version of the document, because this is a document actually, and or of the data. Okay, but if you want, you can manage multiple versions. So for example, if you want to check if the version 1 is still the same that you put some days ago. Okay, instead of using only the last key, the last version. Okay, this is an example of what and how you can do it, and the example is about SMAP. Is in how we do it in SMAP, the software. Okay, our ERP. And I decided to put this example because it is, in my opinion, it's very easy to understand. In SMAP, every single entity in the system has a unique address. Okay, it's made by three coordinates. It's not important to understand what are these three coordinates, but we have this URI, that it's a proprietary URI that identifies in a unique way every single entity inside our system. Okay, and of course, every entity has properties. For example, this is one example of employee entity. This is me as an employee. This is my address. This is my address in a not compact notation, and these are my attributes. Okay, description, what direction I am into, and my job title. This is an example of client or customer. This is the unique identifier, and these are the attributes of the customer. Okay, and the same for a timesheet. Every single entity in SMAP, the purchase order, production order, event, everything we manage inside our ERP is make like that: attributes and a unique key. Okay, unique throughout the whole system. So it's very easy for us to create a key and value store, because this is the key and the attributes or the whole documents are the values, Okay, so every entity is a pseudo document, but you can reach the same with every record in an ERP or in a software, of course, as well as long as you have private key. Primary key, you can treat every record as a document, as a plain document. Okay. But in SMAP, we already have this, and we also have, so every entity can be natively put in the blockchain, because we have the key and the data already ready for being put onto the blockchain. Okay, the data or the state of the object depends on what kind of object is. So in our installation, we used what you will see in a few minutes with this architecture. Every time an object changes, we have an event stream. It's called K21, but it's the internal name of SMAP. Also, this is our internal name. This we have an observer of events. If the observer decided, because we configured this observer to write to the blockchain, this decided to that change might have to be has to be written in blockchain. We just extract the address, the values that we want to write in the blockchain, and we use the smart crypt to write to the blockchain. This is the smart kit, and it is written to the blockchain, and that's a simple example of using it. Let's go into code. How does it work? We have the document. We just need to make an hash of the key and an hash of the value. And then this will be sent to the microservice and to the blockchain. Because we don't want the developer to be aware of this complexity. The developer, this is an example of ERP, of RPG, the developer just need to include a slash copy, this slash copy, then it just have to call this procedure, passing this function, passing key and data in plain mode, so the actual key and the actual data. Okay, the procedure handles all the complex things like encryption and of course also communication in HTTP. So it wraps all the complexity. Okay, and we have a transaction ID. Here we save the transaction ID in a temporary file. That's because the communication with the blockchain is asynchronous. Okay, so we need to check the transaction result. The transaction is the action of writing inside the blockchain. We have to check it in a different process. That's because the blockchain can be very, very slow. It depends on the blockchain we are using. So this operation is non-blocking, and we have to check with the transaction ID and get what the transaction sends back. First of all, the status. Okay. Once we did this writing, we have into the blockchain. This is the log of the blockchain we used. We have these records. So as you can see, they are not readable. This is the version number instead. They are not readable, and this is the key and this is the value. Okay, we also have this is key. This is the version. This is a unique identifier of our let's say contract, smart contract. Okay, so when we want to verify the recorded data, what does it mean verify? It means that the smart kit just has to send the key it wants to verify and the data that the data it has that is to be checked. Okay, this data. So the smart kit handles this checking, this comparison, okay, between the data written in the blockchain and the data and the hash data that are passed to the function, and says if the result is okay. So for example, a developer just need to include the same slash copy, and it has this function passing the key already in plain mode and the data in plain mode, and this wrapper manage all the complex things to retrieve from the blockchain and check the consistency of data. We have two versions. This one is without the version, so it verifies only the latest version, and this one receives a specific version, and it checks if the data is the same of the version, this specific version in the blockchain. Okay, this is the last slide. The Oracle problem. What is the Oracle problem? As you may know, maybe one of the problems of the blockchain is that the whole process must be secured. So if, for example, someone is able to to get into the process just before the data is written in the blockchain, it can, and a hacker, for example, can, if he is very smart, can write its own data on the blockchain, and once it's written in the blockchain, these data are valid. Okay, so one example of solving this problem is to put the logic inside an IoT device. We have this this software. IoT Ready is one of our solutions in IoT, and inside the firmware of IoT Ready, we can encrypt with the private key of the device. This is an IoT device. This IoT device is connected to electrical caliber. Okay, so for example, every time we measure something with the caliber, we can use the private key of the device. This is shipped inside the device. It is not modifiable. It's not temperable. We hash it inside the document, and so we can send the document and the ID of the device, for example, and of course also timestamp to the smart kit that handles the communication with the blockchain in the same way we have seen so far. And it's very difficult to tamper this this algorithm, because it's hard coded inside the firmware of the device. This is just one example, and I think I'm done. No, this is a demo, a video demo. Okay, a video demo of this process. Okay, it's a video demo of this process, and I chose to start it with 5250 because I wanted to point that it works also with a classic, the old style RPG software. And this program was written way before the blockchain was invented. Okay, so what we saw that we are changing the description, the description of this is an item, sorry, because this is in Italian, but this is an item object. You can see kilograms or meters, etc. Okay, so I'm sorry, I go. Okay, so you can see that we make a change in the document. Once we confirm the change, okay, we have a new transaction. This is the log of the blockchain of the yes, the smart kit, the blockchain smart kit. Okay, then we have a new transaction. This is our web interface, because we don't have only 5250 interface. This is the blockchain user interface, Etherscan, for Ethereum. Okay, we see that we have this transaction. This is the data of the transaction, with all the key and the value. And now we want to check if the transaction is valid. Verifica transazione means verify transaction. It's Italian, but understandable. And so clicking on the transaction, we start the verification of the transaction that works as we saw here. Okay. Now I have, okay, it's finished. and I want to thank you. I want also to say that I'm sorry for my English, and that's all. If you have any
Good thing with European speaking English, it's much easier than the Americans or
okay.
British people speaking too fast. No, but thank you very much. This is pretty cool. And you do it right. So this is something you're using today. It's not just something you did for fun, right?
No, we don't use it, but we didn't do it for fun. We don't use it because we like to communicate things internally and externally, if we can, before they are complete, because we need feedback as a developer, and we choose to have this kind of development process when we present things, also if they are not deliverable. Okay, but
Yes.
okay, so we are not using it with the real customers.
Not yet. So anyhow, any question? Just let me unmute yourself and use the chat. If you should be able to raise your hand, right? So that should be, let me see. Oh yeah, turn on the video. No one is raising hand.
Yes.
The only question was Cecilia. Okay, Cecilia, you can see the chat, Mauro?
Yes, I can see the chat, and there's also a raised hand.
For what kind of transactions or operations you apply blockchain in IBMI?
Okay, what do you mean for kind of transaction operation? These use cases is what you
Cecilia, I will.
yes,
Yes,
use case. Okay, for example, one use case is for quality checks. So let me explain. If we have customers that work with O-rings, it's sealing, rubber sealing, and they have to check every now and then for example, the resistance of the material these O-rings are made, and they also have to provide their customers with a certificate telling that the data they have collected during the process of checking, okay, the quality of these O-rings are actually the data they collected from the device. Okay, and this is a very important use case because someone could want to change into the ERP itself, or in the certificate. It is a digital certificate, so it's a recording of data sent to the customer. Someone can could have some reason to change this data, for example, for changing the results of the quality check, and it will be okay, a case where the blockchain is used to be sure that these recordings are not tampered. Another use case that I really like is make sure that some data are written only by, for example, the HR department. I will go back. So I wrote
In the meantime, we have a few questions, Mauro. If we will share the PDF, and we will, right?
Yeah.
And even the recording we can make available
Of course,
Um,
of course.
I will cut 7 minutes in the beginning where we had the technical issues, but
Okay, okay, yes, 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 of course. Okay, so the last case, we want to make sure that the employee data is editable, is modifiable only by the HR department. Okay, how do we do this with the blockchain? Every time the data is, for example, this data, okay, this is an employee, okay, I want only the HR department to change the employee data, or for example the job title of an employee, just to make a stupid example. Okay, what I can do is in this process, when the object is changed, okay, so when the employee data is changed, to use a fingerprint of the HR department. This fingerprint could be a password, or for example, a digital certificate or something like that. Okay, this fingerprint is written inside the data, okay, and saved with a key. If someone tries to modify the actual data on the system, okay, is someone different from the HR department, and if I have, for example, to check if this data have been modified by someone else, I just have to retrieve the data from the blockchain and check it with the same key that the HR department used to write, the same fingerprint that the HR department used to write this data into a blockchain. So I'm sure, 100% sure, that this data has been modified or has not been modified. The third example that I like to point is not the is about IoT. We have sorry, it's about mobile devices. Our mobile devices has the ability to send the position and to get the position, and to use the position, and also of course the time, okay, and to use position and time inside every app installed in the mobile device. Okay, so in our app, what we want to do, this is just a proof of concept, what we want to do it, is every time you change some object, we write on the blockchain, you change some object from the mobile device, of course, you can write into the blockchain the position and the time, the actual time recorded by the device. This can be used, for example, for people who are for delivery, for example, to record that a delivery, an important delivery, is being made, and it can be there can be can't be no one can say that it doesn't have received that item, for example, or that the delivery boy didn't come, because the delivery boy, when it makes a delivery, record this delivery and the status of the delivery, and this is written in the blockchain. Once it's written in the blockchain, no one can go into the database and change any data, because if it does, it doesn't match with the blockchain. I hope I answered.
I guess you did. It was really good answer. Another question from Marco Lanari.
Yeah.
So sorry, my Italian. Yeah, so Cecilia confirmed. And he asked why using the hashes both for key and value? Do you need to have hash for both, or is it for safety or security reason or another reason?
Yes, it's for more than security is for having also the obfuscation of the data, so we don't have to concern about what data is written to the blockchain. But it's not mandatory. You don't need to use the value. I'm talking about the value, of course. You don't have to use the hashed version of the value. This is one of the reasons. The second reason is that you are putting into a very small number, very small, it's 265 bytes, but it's smaller than, for example, you know, the measurement of 1000 temperature in for example of an oven. Okay, if you want to keep track of the temperature recorded, the temperature profile recorded by an oven, okay, if you have a plain data, you have, for example, 100, 200, 300, 500 or 1000 numbers that you have to put onto the blockchain. But you don't need to put this data on the blockchain, because the same data remains in your system or whenever you want. What you want to know is that no one has changed that data. So if I change just one temperature recording, which is just one value, the hash will be different. And so if the hash is different, it means that the blockchain has a different hash, and so you can check it.
Good. Another question. I'm a newbie on blockchain, but if the blockchain is hosting on IBM blockchain platform, how can I set it up? How can I set it in the SMEAP API?
Okay. If the IBM, yes, I understand. It's I don't know if the IBM blockchain platform uses EVM, but if this is Hyperledger Fabric, that is the name of IBM's IBM Cloud blockchain solution, yes, it does. So you just have to configure the our market here. No, down. Okay, here the Go middleware to talk with IBM blockchain instead of Ethereum, that is the blockchain we used to our tests. Is Ethereum right, Paolo? We use a test environment of Ethereum. I don't remember the name. Yes, that's the Ethereum test.
Yes.
Okay. Thank you, Paul.
Good. Okay.
Did I answer, Manuel?
Okay. Thank you. Yeah. Good. So thank you. This is a really AI for inspiration, right? So this is really inspirational, and I'm quite sure we'll come back to you, Mauro, on this topic more than once, in one way or another.
Okay.
So thank you so much also for this. And again, I will cut it down in the beginning, and then we will publish it on YouTube. And of course, the PDF we can share, right, Mauro?
Yeah.
And we can, I will put up your contact information so they can reach out to you as well.
Yes, yeah. I guess you have also the contact on LinkedIn, because this was made through LinkedIn, so you can reach me out whenever you want. And thank you for being here.
Thank you all, and thank you, Mauro. Bye-bye.